Newton's first law explains the type of motion to be expected in the absence of a net force. Objects will either remain at rest or travel with a uniform velocity along a straight line. Newton's second law, on the other hand, explains the type of motion which will result when a net force is acting on an object. Specifically, a net force will cause an acceleration which varies directly with the applied force and inversely with the mass of the object. The acceleration will always be in the same direction as that of the net force. To observe the motion described by the second law, a magnet is positioned underneath a glass plate and will be used as a means to provide a net force to a steel ball. The amount of force which the ball experiences will depend upon the distance between the ball and the magnet. If the ball passes directly over the magnetic force initially accelerates, then decelerates the ball, and finally brings it to rest. The net force can be seen to produce an acceleration that not only causes a change in the object's speed, but also an acceleration which brings a change to the direction of the object's velocity. Traveling at an angle relative to the direction of the magnet's applied force, the ball is observed to accelerate in the direction of the force. Traveling closer to the magnet results in a stronger net force, and a greater acceleration is seen by the increased change in the ball's path. In this trial, the ball is accelerated as the magnetic force acts in the same direction as the ball's motion. It is then decelerated as the net force acts in a direction which is directly opposite to the ball's motion. With the proper combination of velocity and net force, the ball can be accelerated and made to travel in a semicircular path as it is redirected in the opposite direction. Together, Newton's first and second laws of motion can be used to predict and explain the endless variety of motion which make up a significant portion of the study of physics.